Hey there, Mustangs. Welcome back to another edition of No Here, No Problem. Rosenwald here. We're going to be working on the Unit 4 review, which relates to solving. So let's dive right in because we got a lot of problems to go through here, okay? So when we're looking at quadratics, there's a process that we always want to try to follow. We want to look to see if there's a GCF, meaning is there something that all the terms have in common? Are there two terms? Are there three terms? Is the leading coefficient 1? Is the leading coefficient not 1? Is there an x squared and no other x's in the problem? And when all else fails, can I just use the square root, the quadratic formula? So there's a lot of things to go through. And again, the best way to practice doing these and to get the hang of it is just to dive in and just keep doing problems, okay? So we're going to start here on number 1. The first thing we're going to do is, like I said, we're going to look to see if there's a GCF. Now, before we actually jump in, I want you to recognize the fact that this says solve. Anytime we're solving, that tells us we have to actually find what is the answer for each one of these. What does x actually equal? And we look at the degree. The degree here of 2 tells us that there's going to be two answers for this, okay? So let's get started. First, I'm going to look for a GCF. In this case, there is a GCF. When we look at the 2 and the 10, I could divide both of these by a 2. Not only that, I look at the fact that there's an x squared here and an x in the second one. So I know at the very least there's an x in each one of these, okay? If I divide each of them by that 2x, what we're going to end up with here is just an x on the first part because the 2's cancel and one of my x's cancel. And then for the 10 divided by 2, we're going to have a 5, so that's equal to 0. Now we're done taking out the GCF, so we use the zero product rule, which says that we take each one of our factors that's here and we set those each equal to 0. So we're going to take first this 2x and set that equal to 0. And then we're going to take the x plus 5 and set it equal to 0 as well. Divide by 2 on the first part, and we end up with x is equal to 0. Subtract 5 on the second part, and we get x is equal to negative 5. And that's it. You're done with that problem. All right, let's move on to number 2. Let's look for a GCF. There's no number that I could divide all of them by, but they do have an x. So let's take the x out from each one of these. Divide by x, divide by x. We end up with an x minus a 36. There's nothing else we can do to factors, so now let's use the zero product rule. So let's set each one of these equal to 0. We get x is equal to 0, and we get x minus 36 is also equal to 0. Solve for this, we get x is equal to 36, and there's your two answers, 0 and 36. All right, let's take a look at number 3. We look for a GCF, and we do not see anything that we can divide everything by. Yes, there's an x here, and yes, there's an x here, but this third term here does not have an x, so they don't have an x in common. We look at the 8 and the 6 and the 1, and we say, do they have any numbers in common? Well, they don't have anything that they can all divide by. So then we try, well, are there two terms or three terms? Since there's three terms here, we can see the fact that there's three separate terms. There's 1, 2, 3 terms here. When there's three terms, what we look for is if it's possible to find factors of 8, okay, that will give us a negative 6, okay? And when we look for the factors of 8, we're looking for 1 and 8, 2 and 4. And the only way that we can get a negative 6 is if we have a negative 2 and a negative 4 from this list, okay? And when we check them, negative 2 and negative 4 adds up to negative 6. But then when we multiply, negative 2 times negative 4 equals positive 8. Let's go ahead and take each one of these. We get x minus 2 equals 0 because that's a negative 2 there. And then we have x minus 4 is equal to 0. And we have x is equal to positive 2 and x is equal to positive 4. Those are your two answers. Okay, let's take a look at number 4. Number 4, for every quadratic, I should have said this earlier, we always want all the quadratics to always be equal to 0 before we start trying to solve them. So let's move everything over so it's equal to 0. I like to keep my leading term positive, so I'm not going to move that. What I'm going to do is I'm going to take this 8x and we're going to move it over. If we move it over, it's going to change from a positive into a negative 8x, okay? If I move this over, it's a negative 4, so if I move it, it's going to turn into a positive 4, and all that's going to be equal to 0. Now, the first thing we should look for is the leading coefficient, since there's three terms. The leading coefficient here is not equal to a 1, it's equal to a 3. So then we'd say, well, all right, well, what's the next process from this? What we're going to do is we're going to look for, is there any way that I can factor this using the guess and check method because it's not a leading coefficient of 1? Well, let's try the guess and check method and see if we can get this to work out. The factors of 3 are 1 and 3. So the only values that we can have here are a 3x and a 1x. Okay. The factors for 4 are 1 and 4, 2 and 2. Those are the only options. And if you guys remember, I said 99% of the time we're not going to use the 1 and the 4. Okay, majority of the time it's going to be the other values. Let's try 2 and 2. Let's check. 3 times 2 is 6. 2 times 1 is 2. I'm trying to get a negative 8 here. So if I needed that, I would have to have both of them be a negative so that we end up with a negative 8 when we add these together. Okay, so there's our signs. We know everything is now set. Everything works out. And so if I put in a negative for both of these, that's how we get a negative 6x. And then we get a negative 2x to give me that negative 8x. If we take each one of these now and set them equal to 0 and solve, we'll take this and set equal to 0. We have 3x minus 2 is equal to 0. We're going to add 2. So we're going to get 3x is equal to positive 2. Divide by 3. We get x is equal to 2/3. Okay. And then here we've got x minus 2 is equal to 0. We're going to add that 2. We get x is equal to positive 2. So my answers for this are going to be 2/3 and then positive 2. Okay. All right, number 5. Again, we want everything to be equal to 0. So I'm going to go ahead and move that negative 4 over. So we're going to have a 6x squared minus a 10x. And then because I moved that 4, it turns into a positive 4. Okay, it was a negative. Now it's a positive when we move it. Look for a GCF. 6, 10, and 4 are all even numbers. So we know at the very least they all have a 2 in common. So let's take the 2 and divide that out. If I take this 2 out, we're going to be left with 3x squared minus 5x plus 2 is going to equal to 0. And that's just dividing everything by 2. We look at the leading coefficient of this, and it's a 3. And so we say, well, can I do guess and check to see if I can get this to work out? Well, let's try. The only factors of 3 are 1 and 3. So we'll put in we'll put in a 3x, and we'll put in a 1x, okay? The only factors of 2 are 1 and 2, okay? And we're going to try to get a negative 5 when all is said and done here, okay? So if I just throw them in, 1 and 2, I'm just going to guess and check, and we're going to see what happens here. If I multiply this together, that's going to give me a 6x. If I multiply this together, this will give me a 1x. I need to go through and set it up so I get a negative 5. So 1 minus 6 will give me a negative 5. But watch what happens here. If I put my negative here and I put my positive there, what's going to happen is right here I get a positive times a negative. And a positive times a negative is going to equal a negative. But when we look here, I've got a positive 2. So my signs are wrong. Okay. So we guessed, we checked. Let's go ahead and erase it and let's start over, okay? Let's try taking the 2 and the 1 and swapping their places. So I'm going to put the 2 here and the 1 here, and now let's see what happens. We end up with 3x. We end up with 2x. I need to get a negative 5x. So the only way that that's going to work is if we have a negative 2 and a negative 3. So we'll put the negatives in there, and we check it out. All the signs work out. Negative 2 and negative 1 equals positive 2 when we multiply them. And negative 3x and negative 2x, when we add them, adds up to negative 5x. Okay, let's solve each one of these. 3x minus 2 is equal to 0. We're going to add 2, so we get 3x is equal to 2. X is equal to 2 over 3. We're going to take the x minus 1 is equal to 0. Add 1, we get x is equal to 1. And these are your two answers. All right, take a look at number 16. When we see, there's two ways to actually do this. I'll show you both ways, but when we have an x squared in the problem and nothing else in the problem, I personally like to use the square root method. I would divide by 16 on this and divide it by 16. We end up with x squared is equal to 9 over 16. We take the square root of both sides, and when we take the square root, we cannot forget that we use a plus and a minus, and we end up with a positive 3 over 4 because the square root of 9 is 3 and the square root of 16 is 4. If you did not recognize that that was square root method, we can go ahead and try solving it the way we were just doing this, which is to move the 9 over, And then we look at this and go, oh, look, there's two terms and they're both perfect squares and there's subtraction. So because they're both perfect squares and a subtraction, we use our difference of squares formula. For 16, we get 4 times 4. For x squared, we use x times x. And then for 9, we're going to use 3 and 3. And plus and minus. So we get x is equal to, for this first part, we get a negative 3 over 4, because I'm going to take this 3 and move it over when I'm solving to give me a negative 3, and then I divide by the 4 that's there. Okay, I'm going to take this negative 3 and move it over, and when I move it over, I end up with a positive 3 over 4. And so my answers are positive, negative 3/4. Okay. All right, let's keep going. So these say to use the quadratic formula. I'm going to actually say bah humbug, okay? I'm going to try to avoid using the quadratic formula unless I absolutely need to, okay? So first thing I'm going to do is I'm going to look at the 32 here and see if I can get any factors that will give me a negative 4. 1 and 32, 2 and 16, 4 and 8. All of these work to give me 32. But when I add and subtract them, the 4 and the 8 here is going to work. If I did 4 minus 8, that would give me a negative 4. So that's going to work, right? But again, we should always check all of our signs when we do this. So we're going to go x plus 4 and x minus 8 equals 0, because that's what people would do. And when we check it, always check. Negative 4 and negative 8 gives me negative 4. That works. But when I do negative 4 times negative 8, that does not give me a positive 32. It gives me a negative 32. Okay? So that tells us that this is not actually the right way to do this, that this is wrong, that did not work, and therefore this is not factorable. So we have to use the quadratic formula. We get x equals opposite of b. So my a is 1, my b is negative 4, and my c is 32. The opposite of b is to do positive 4, because it's a negative 4, we use the opposite, plus or minus the square root of b squared, which is going to be negative 4 squared, minus 4 times a times c, all over 2 times a, which is just 2 times 1. So we have 4 plus or minus the square root of, this will be 16, what is that, minus 128 over 2. We're going to get x is equal to 4 plus or minus the square root of, what is that? It's officially late and my brain is just not braining right now. 16 minus 128 is 16 minus 128. So I thought negative 112. Okay, over 2. And then we see if we can simplify this at all. Okay, and if we look at what is simplifiable, if I took 112 and divided it by 16, that's going to actually work. So this 112, we can break this up into negative 16 times 7. Okay, and we learned that when we went negative and we're doing the square root, that's just going to turn into a 4 square root 7, but the negative makes it an I. So it's going to be plus or minus 4 root 7 I. And all of that is over 2. Okay. Now we need to take these and break them up and simplify them if we can. So let's simplify these. We're going to have 4 over 2, which is our first fraction, plus or minus our second fraction, which is 4 root 7 over 2, and then I. 4 divided by 2 is 2. 4 divided by 2 is 2. Root 7 I. And there's your final answer. All right. Oof, got a lot of problems to do still. All right, number 8. Let's work through this one. Get everything equal to 0 before we even start solving. If I move the x squared over, we're going to subtract x squared. So that's going to be a 2x squared. Move the 19x over by adding 19x. That means we're going to be at plus 11x. And then plus 5 is equal to 0. Okay. I'm going to see if guess and check works here. Okay. The only factors of 2 we can use are 2x and 1x. The only factors of 5 we can use are 5 and 1. Let's guess and check. So this will be 10. This will be 1. 10 plus 1 does equal 11. And 1 times 5 does equal 5. So we got it. First try, we got it. Okay. A lot better than the quadratic formula. Take this and set equal to 0. We're going to have 2x plus 1 is equal to 0. Move the 1 over, we get negative 1. Divide by 2, we get negative 1/2. Okay. Take the x plus 5, set that equal to 0. We get x is equal to negative 5. And there's your two answers. All right, let's take a look at the next one, number 9. Move everything over so it's equal to 0. Move this over, it's going to be minus 7x. Move this over, it's going to be minus 15. And all that's going to equal to 0. I'm going to fix this. It was super sloppy. All right, let's see if we can do guess and check for this because the leading coefficient is not 1. Okay, so I'm going to go with 2x and 1x. For the 15, I'm going to do 1 and 15, 3 and 5. Okay, I'm going to try 5 and 3. So let's check it. We get 10, we get 3. And so that's going to work. I need a negative 7, so that means that this has to be a negative, which means that's a negative, that's a positive. And that checks out. So let's go ahead and solve this. We get 2x plus 3 is equal to 0. 2x is equal to negative 3. Divided by 2, we get x is equal to negative 3 over 2. And then we have x minus 5 is equal to 0. Solve for x, we get x is equal to 5. And there's your two answers. Okay. All right, let's move on to number 10. Again, let's try to get everything to be equal to 0. So I'm going to move this 10x over. That means we're going to have 2x squared. This will be minus 10x, so that means that we're going to have a negative 6x. Move this 3 over, we'll have a minus 3, and that's going to equal to 0. Let's just try guess and check, see if it works. So I know I'm going to be using, for this first term, a 1 and a 2. So we have 2x next. I know I'm going to be using a 1 and 3 here, so let's just test them, see where they go. Let's try a 3 and a 1. That means we have 6x and 1x. I can't get a negative 6 from these two, so that won't work. So let's try rearranging their order. We're going to have 3 and 1, which will give me a 2x and a 3x, which that still does not give me a negative 6. So that tells me that from here, it's not actually factorable, and so we end up having to actually use the quadratic formula. So we have minus 6x and minus 3 is equal to 0. Let's go ahead and start. X equals opposite of b, that's a positive 6, plus or minus the square root of b squared minus 4ac all over 2a. That didn't exactly flow as much as I would have liked it to. I was trying to write while singing at the same time. So we get x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right. And now we just simplify it. So we have positive 6 plus or minus the square root of, this is going to be 36. 4 times 2 times 3, that's 24. So it's going to be plus 24 over 4. So we had x equals 6 plus or minus the square root of, that's what, 60 over 4. 60 can actually be reduced, so we're going to have 60. We can break that up into 4 and 15, which will be 2 root 15. So we're going to have x is equal to 6 plus or minus 2 root 15 over 4. Over 4, sorry. And then remember we said we're going to go ahead and break these up and simplify. So we're going to get 6 over 4 plus or minus 2 over 4 root 15. So we have divide by 2. We have 3 over 2 plus or minus 1/2 root 15. And there's your two answers. Okay. All right, next, got a few more here. Now we're on to square root method. When we're doing the square root method, remember that means that we're trying to isolate the squared portion. So that means that that x squared has to be alone. So let's take this 11 and move it. We end up with 2x squared is going to equal 6. That's when I subtract 11 from both sides. Divide both sides by 2. We end up with x squared is equal to 3. Take the square root of both sides. We get x equals plus or minus root 3. Okay. Next one, we are going to try to isolate the squared portion. So we're going to have 3, x minus 2 squared. We're going to take away 1 from both sides. So we end up with 12. Divide by 3. We get x minus 2 squared is going to equal 4. Take the square root of both sides. We end up with x minus 2 equals plus or minus 2. We're going to add 2, so we get x equals 2 plus or minus 2. Now think about what these are. 2 plus 2 is 4, and 2 minus 4, or I'm sorry, 2 minus 2 is 0. So those would be the two answers there. Okay. All right, let's do our simplifying our complex numbers. These are just combining like terms. So we have 9 minus 3i. We're going to distribute the negative, so we have minus 11, and then we minus 14i. Okay, that's just distributing a negative. We end up with a negative 2 minus 17i, and we are done. Next one, we've got multiplication going here, so we have to do a little of FOIL. So 9 times 11 is 99. 9 times 14i is going to be 90 and 36, so 126i. Negative 3i times 11 is negative 33i. And then we end up with a negative 42i squared. Now the doozy here is this one right here. Remember that I squared is equal to a negative 1. Okay, so that means if I have a negative 1 right here times a negative 42, we're going to end up with a positive 42 when all is said and done from that number. Bring down the 99, and then we have 126 minus 33, which is 93i. We'll put stuff together, so we get 99 plus 42, which is going to be 141 plus 93i. There you go. All right, next ones, we're going to just multiply these out. So we have, let's see, 2 times 3 minus I times 3 minus I. That's what that square means. I personally like to multiply out the binomials first before I distribute the 2. I'm going to save this 2 for later on. We'll deal with that in a moment, but let's deal with the other parts here. So just looking at this portion right here, when we multiply that out, we're going to have 9 minus 3i plus positive I squared. Okay, that's just doing FOIL. If we simplify that, we're going to have 2 times, this will turn into a negative 1, so that'll be 8 minus 6i. And then we simplify from there, we have 16 minus 12i. Last, number 16, we're going to be doing the conjugate here. The conjugate of 7 minus 2i, remember, is the exact same thing. It's just going to change the sign. So if I have 7 minus 2i, I'm going to have 7, 2i, 7, and 2i. In place of our minus, we're going to put a plus. Okay. The reason we do that is the conjugates will go ahead and cancel themselves out in that denominator. When we look at the bottom, we're going to end up with a 49 plus 4. Okay. You can multiply that out. You can use your calculator and everything, okay? But we get 49 plus 4. And then on the top, I have 35i plus 10i squared. So if we simplify this, we're going to have a negative 10 on the top, a positive 35i, and then we're going to have a 53. But remember, in a plus bi form, we have to break this up. So this will be negative 10 over 53 plus 35 over 53i. And this gets broken up and this gets broken up, okay? That is all. That is it from the review. So if you have any questions, please reach out. But I encourage keep doing the Delta math, and hopefully you guys will get the hang of this before our test here, okay? You guys take care. Have a wonderful day. Stay safe, stay responsible, and have a good one.